Okay, so section 11.8 is something that we call combinations, okay? This differs slightly from permutations, which is what we did in 11.7. So let's see what a combination is. It says a combination is any distinct, is a distinct group or set of objects without regard to their arrangement. Okay, so the first example here is going to ask us, is this a permutation or combination? Okay, so the difference is in a combination, the order is not important. That's what it says without regard to their arrangement. Okay, that means order is unimportant. Order is unimportant, okay? So the questions for example number one is going to ask us, is this a permutation or is this a combination? We're not actually going to figure out we're not actually going to solve the problem. We're just going to figure out, is it a permutation or combination? Okay, so it says a group of 5 friends, Arlene, Inez, Judy, Dan, and Eunice, are forming a club. The group will elect a president and a treasurer. And how many ways can a president and treasurer be selected? Okay, so what they're saying here is out of these 5 people, they're going to elect a president and a treasurer. So the first person that they choose is going to be the president, and the second person they choose is going to be the treasurer. So if I think about that, suppose we pick Inez and then Dan. Then this means that Inez is the president and Dan is the treasurer, and that would be different if we pick Dan and then Inez, because then Dan would be the president and Inez would be the treasurer. So part A, because the order is important, this is going to be what we call a permutation, which is, again, what we did in 11.7. Now, part B, it says, of the 5 individuals named, 2 will be attending a meeting together. And how many ways can they do so? Okay, so if we pick Inez, they're just going to go to a meeting. And Dan, right? That's the same thing as picking Dan and Inez, because they're going to the same meeting, right? So it's not like, the first person is more important than the second person. So this here, because the order is not important, this is going to be a combination, right? So, guys, if you think about, like to me, which is the ultimate taco, because it's so basic, bean and cheese, right? Isn't that the same thing as cheese and bean, right? Bean and cheese and bean. Papa con huevo, huevo con papa. It's all the same, right? All right, so now let's go ahead and move on. Yes, I like breakfast tacos. I'm sure everybody do. Okay, so here's our combination formula. So there is a formula and how to do the combinations. Again, I'm going to be using my calculator to do this, so I won't actually use a whole formula. I'll just use the combination option on my calculator, okay? So it says the number of combinations when R objects are selected from N. So we have a total of N, and we're going to pick R of them. Here's our combination formula. Okay, so let's take a look at example number 2. And it says, in your American history class, you're assigned to read any 3 books from a list of 8. How many ways can you select 3 of the 8? So what we're going to do is we're going to say this is going to be 8 combination 3. So we're going to have 8 books. We're going to choose 3, okay? So the way I'm going to show you this on the calculator, let me go ahead and get mine running. Here it is. Okay, clear. So on this calculator, guys, I'm going to hit 8. I'm going to come back to my math. If you remember from 11.7, I'm going to get to that PRB. So I can go, one way I can go is hit this little right arrow 4 times to the right, or I can just go once to the left. And there it is. And then we're going to hit the number 3. And so there's 56 ways that we can choose 3 books out of the 8. Okay? 56 books. Now, guys, on your calculator, you're going to have to look to see where those buttons are. So I'll tell you right now that if anybody has any kind of a TI calculator, it doesn't have to be a graphing calculator, guys, but if you have a TI, if it's just a regular scientific calculator, you should see a button that says math. And again, when you click it, there'll be a PRB. You'll go to it and you'll be able to see it. So it doesn't even have to be a a graphing calculator. It'll be similar. If you are on a Casio calculator, okay, So if you're using a Casio calculator, somewhere down here you have the multiplication symbol, and somewhere over here you have the division symbol. And I want to say above those, you'll see like an NCR and maybe an NPR, something like that. You should see them somewhere on your Casio calculator. And guys, the way you're going to get to that is you're going to hit the shift button, right? So if you were doing this on a Casio, you would hit 8, then you're going to hit shift. And then I want to say again, it's either going to be right above the multiplication or right above the division. I don't remember off the top of my head right now, but you'll hit that and it should do something like, I think it'll just put a C, and then you'll hit the number 3. And I want to say somewhere down here you have an enter button, right? And you'll get your 56, okay? So again, that's for if you have a Casio. Alrighty, so let me keep scrolling down. Okay, another problem, very similar. Let's take a look here. It says, Jan has 10 photos from which she's going to choose to hang 6 on a wall. And how many ways can she do so? Okay, so we're going to go 10, choose 6, right? One more time, I'm going to grab my calculator. Let me clear that out. So let's go 10, math, probability, choose 6, and then equals or enter 210. There we go. Okay, and so now let's take a look at example number 4. It's talking about dinner combinations. At an Oriental cafe Chinese restaurant, a dinner consists of choosing 3 items from A, 4 items from B, and 3 items from C. Okay, so look how many A has. It tells me A has 5, tells me B has 7, and it tells me C has 6. Okay, so we're going to go like this. Let's do this. Let's go like this. A, B, and C. Okay, so from A has 5. So we're going to have 5, and we're going to choose 3 of them from A. Okay. Now B has 7, and we're going to choose 4 from B. C has 6, and we're going to choose 3 from C. Now the way we're going to do this, guys, is we're going to multiply each of those, okay? So again, on my calculator, the way I'm going to do this, I'll go 5, let's go math, PRB, choose 3, okay, times, now the way I'm going to go ahead and do this, I'm going to go put all these things in parentheses, okay? Let's see, 7, math, PRB, choose 4, parentheses, times, let's see, what was the last one? 6, math, PRB, choose 3.
Hello?
Give me one quick second. Okay, so let's see. So we multiply everything out, and we came up with 7,000, right? So right here, type in 7,000. So there's 7,000 different combinations available, right? It's a lot of different combinations. All right. So the next couple of problems here, at least these 3, they're just calculator type problems just to make sure that we understand how to do this. So again, on this calculator here, actually, you know what? Let me show you. Let me see if I can get it going here. Calculator. There we go. I'm curious to see if this one has it on here. It has the factorial button, but I don't see it having. Let's see. Programmer, I don't think this is what we want at all. Trig function, no. No. Okay, so it's not on here. Okay, it's all right. We'll just use my regular calculator that I was using earlier. Okay, so I'm going to go 12 Math, probability. We're going to go permutation this time. 8. And wow, 1995, 8400. So 1995, 8400. Okay, and then we'll do the same thing we did before, but now we'll do combinations. So math, probability, combination 8. It's going to be a lot smaller, I want to say. 495. Okay. All right, so now we have 5 choose 3. So let's go 5 choose 3 is, oops, what did I do wrong? Oops, I forgot to put the 3. 3 is 10. And then 9 choose 3. So second entry, then come back right here, delete, insert the number 9. There we go. 84. All right, and then these guys, I'm just going to divide them both by 2. So half of 10 is 5. Half of 84 should be 42. Okay. Let's see. So we got a few more here. It says an ice cream parlor has 20 different flavors. We're going to get a banana split with 3 different. So 20 choose 3. Again, so the reason how I know this is going to be a combination, not simply because I'm in the section 11.8, but think about it this way. You're going to pick 3 different flavors of ice cream. Chocolate, vanilla, strawberry. It's the same thing as picking vanilla, strawberry, chocolate. You know what I mean? The order is not important, okay? So let's do this again. Second entry. I'm going to delete that. I'm going to insert the number 20. Okay, and we're choosing 3. So 11,400. Wow, that's a lot of different combinations for, or sorry, 1,140, not 11,400. Okay, let's see. Let's take a look-see at the next one here. We're going to have 5 cards. How many ways can 3 kings and 2 queens be dealt? Okay, so in our deck of cards, we know that there are 4 kings. We know that there's also 4 queens. So out of the 4 kings, we want to choose 3 of them. So it's going to be 4 choose 3. Out of the 4 queens, we're going to choose 2 of them. Okay. So I'm going to go 4 choose 3 times 4 choose 2. Okay, so let me go ahead and do parentheses. 4 choose 3 times 4 choose 2 for the 2 queens, and coming up with 24. So 24 different ways we can make that happen. All right, so almost done here. It says Jamie has 7 CDs and wants to take 4 with him to work. 7 choose 4, right? The 4 that we pick, the order and we pick them is not important. 35. And I think a couple more here to see. Sears has 10 different microwaves, 6 different, so 10 microwaves, 6 dishwashers. We're going to pick 3 of the 10, so 10 choose 3, and 2 of the 6, so 6 choose 2. Okay, so let's do that again. Parentheses, 10 choose 3, close it off, times 6 choose 2 gives me 1,800. Boom, there we go. Good. There we go. Okay, this is the last one. So Joseph is sent to the store to get 5 different bottles of regular soda, 3 different bottles of diet soda. So we know we have 10 types of regular soda. So we're going to go 10. We're going to choose 5 of those. And then times 7, choose, we want 3 different diet sodas. Okay, so again, guys, I'm just going to do this like this on my calculator with the parentheses. So, excuse me, 10 choose 5 times, oops, I need to exit here, quit, 7 choose 3, and I'm coming up with 8,820. So 8,820. And that, my friends, is section 11.8.